Hello dear students, welcome back to the online classes. In this class, I am going to discuss about the last bit of this topic, that is uniform motion in a straight line and the equation for this uniform motion or the formula for this uniform motion. The uniform motion means the body covers or the body is said to be in motion, uniform motion, if it undergoes equal displacements in equal intervals of time. Our body covers equal displacements in equal intervals of time, then it is called uniform motion. A body is said to be in uniform motion if it covers or if it undergoes equal displacements in equal intervals of time. Now I am going to find the equation for that uniform motion or formula for the uniform motion, and that object is moving with the uniform velocity along the straight line. Uniform motion in a straight line. Suppose if I consider the body is initially situated at this point. The body is initially situated at this point. This is the one point. The body is situated at this point O. Now this bodies move along the straight line along this axis OX. The body is moving along the axis. This is the axis. The body is moving along this straight line along the OX. An object is said to be in uniform motion if it undergoes equal displacements in equal intervals of time. Now consider this the object. The object is situated at this point. This is the any1 object. This object is moves with the uniform velocity v along the straight line OX. Along the straight line OX with O. Along the straight line OX with O as the origin. O as the origin means E point in the object move. Now from point O to A, the body moves from point O to A when a time t equal to 0. The body moves from point O to B, then when time t equal to t1. The body moves from origin O to C when a time t equal to t2. Here x0 or x0, x1 and x2 are the displacement of the body when a time t equal to 0, t1 and t2. This is a very simple concept. The body is situated at this point. This body is move along the x-axis. When a time t equal to 0, the body is situated at this point. This is x0. The time t equal to t1, the body is situated at this point, that is x1. When a time t equal to t2, the body is situated at this point, that is x2. Here x0, x1 and x2 are the displacement covered by the body. It covers equal displacements in equal intervals of time. This is the point A and this is the point B and this is the point C. From using this concept, now I am going to find the formula for this uniform motion. Here in this diagram, this is the diagram. In this diagram, the objects at the position A and B and C when a time t equal to 0, t equal to t1 and a t equal to t2. From using this diagram, O to A is equal to O to A. This is the origin of that body. O to A is equal to x0. O to A is equal to x0. Then O to B is equal to x1. O to B is equal to x1 and O to C is equal to x2. O to A is equal to x0, O to B is equal to x1 and O to C is equal to x2. Then A to B is equal to A to B. A in the B antandre yenagatte illi? Here A to B, it moves with along a straight line with the velocity v. With the velocity v. When the body moves along the straight line with the velocity v, we know the formula velocity is equal to displacement divided by time. Then x is equal to or x1 is equal to v into t. X1 is equal to v into t. Here AB is equal to V into T1. The rate of change of displacement is called velocity, and AC is equal to A to C. The rate of change of displacement A to C is equal to V into T2. V into T2. Here, from using this diagram, O to B is equal to, here, from point O to B is equal to OA. O to B is equal to OA plus AB. From using this diagram, O to B is equal to OA plus AB. Here, O to B, O in the B ವರೆಗೆ ಇರತಕ್ಕಂತದ್ದು ಏನದು equation, that is x1. O to B is equal to x1. x1 is equal to O to A, that is x0, plus A to B, that is V into T1. V into T1. x1 is equal to x0 plus V into T1, that is equation number 1. OB is equal to OA plus AB. x1 is equal to x0 plus V into T1. And from using this diagram, again I can write another equation. O to C is equal to, from this distance, O to C is equal to OA plus, O to C is equal to OA plus AC. Therefore, O to C is, that is x2. x2 is equal to OA is x0. x2 is equal to x0 plus V into T2. V into T2. That is equation number 2. x1 is equal to x0 plus V into T1, and x2 is equal to x0 plus V into T2. Now, the subtract these two equations. Subtract equation 2 from 1, or equation 1 from 2. Subtracting the equation 1 from 2. When you are subtracting equation 1 from 2, we get x2 minus x1. x2 minus x1. Here x0 and x0 cancel each other. Then the velocity V is the common. x2 minus x1 equal to V into T2 minus T1. x2 minus x1 is equal to V into T2 minus T1. This is the equation. When you subtract the equation 1 from equation 2, x2 minus x1 is equal to V into T2 minus T1, or x2 is equal to x1 plus V into T2 minus T1. x2 is equal to x1 plus V into T2 minus T1. This is the equation for the uniform motion. It is a very simple concept. When the body moves along the straight line with the uniform velocity V, OX, along the straight line OX, with the O is the origin. Here OA equal to x0, OB equal to x1, OC equal to x2, and AB equal to velocity with respect to time. From using this formula, then AC is equal to V into T2. From using this diagram, we can write equation number 1 and 2. When you subtract the equation 1 from equation 2, we get this equation. x2 is equal to x1 plus V into T2 minus T1. This formula is used to find the uniform motion when it is in straight line. x2 equal to x1 plus V into T2 minus T1, or x1 is equal to x2 plus V into T2 minus T1. This is a very simple equation. That now we will move to the next concept, that is relative velocity. The relative velocity ಅಂತಂದ್ರೆ ಏನು? The rest and motion both are relative term ಎಂತಕ್ಕಂಥ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ನಾನು ಆಲ್ರೆಡಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ ಫಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ. ಇಲ್ಲಿ relative velocity means it is the velocity of one body with respect to another body, or the velocity of one body with regard to the another body. This is called relative velocity. The velocity of one body moving with respect to another body, or velocity of one body with regard to the another body. It is called relative velocity. Now I will discuss one beautiful example. Consider two cars A and B are moving parallel to each another with the velocities. ಎರಡು ಕಾರು ಒಂದು ಡಬಲ್ ರೋಡಲ್ಲಿ ಎರಡು ಕಾರ್ ಮೂವ್ ಆಗ್ತಿರ್ತವೆ. ಕನ್ಸಿಡರ್ two cars A and B are moving parallel to each other with velocities VA and VB. VA and VB are the velocities of the two cars moving parallel with each other. The relative velocity of A with respect to B. The relative velocity of A with respect to B. ಎರಡು ಕಾರುಗಳು ಮೂವ್ ಆಗಬೇಕಾಗಿತ್ತು. Here this is the car A and this is another car B. This is another car B. Right? Okay, this is the car A and this is the car B. These are the two cars. These two cars are moving parallel with each other with the velocity VA and this is moving with the velocity VB. The relative velocity of A with respect to B. Relative velocity means the velocity of the one body with regard with the another body. Here the relative velocity of A with respect to B is, then you can write this equation, VAB is equal to VA minus VB. VA minus VB means velocity of the body A minus velocity of the body B, or velocity of the car A minus velocity of the car B. Here VA is the velocity of the car A and VB is the velocity of the car B. Now the relative velocity of B with respect to A, that is velocity of the car B with respect to A. Here in this diagram, this is the relative velocity of the car A with respect to B. Here the relative velocity of the car B with respect to A, that is VBA is equal to VB minus VA. VA minus VB is velocity of the car A with respect to B. VB minus VA is velocity of the body or relative velocity of the car B with respect to A. Then you can write that equation, VB is equal to, here VBA is equal to VB minus VA, or the relative velocity of the car A with respect to B is, that is VA minus VB. The relative velocity, this is the first equation, relative velocity of the car A with respect to car B. The second equation is, this is the relative velocity of the car B with respect to A, that is VBA is equal to VB minus VA. Suppose if the two cars are moving in the opposite direction, this is the car A and this is the car B. The two cars are moving with the opposite direction, this is the VA and this is VB. Suppose these two cars are moving with the opposite direction, then you can write this equation, the relative velocity of A with respect to B is VAB is equal to, VA minus VB is right, but the body B is in opposite direction. This is very simple. Here the actual equation is VAB is equal to VA minus VB, but when the car is moving in the opposite direction, you put the negative symbol here. VAB is equal to, the relative velocity of the car A with respect to car B is VA minus VB. When the car B is moves opposite to the direction of the car A, here this is the minus VB, minus into minus, you get this equation, VAB is equal to VA plus VB, the relative velocity of the car A with respect to B, or the relative velocity of the car B with respect to A. Car B with respect to A, VBA is equal to VB minus VA is equal to VB plus VA. These are the equations of relative velocity. Relative velocity means it is the velocity of the body with respect to another body. The velocity of the body or the body is moving with a certain velocity with another velocity, or the velocity of one object with respect to the another moving object. This is called relative velocity, and these are the equations when the body moving in the same direction. The velocity of the body A with respect to B is, that is, VA minus VB, or the velocity of the body B with respect to A is, that is, VB minus VA, or moving in the opposite direction. VAB is equal to VA plus VB, or VBA is equal to VB plus VA. These are the equations of relative velocity. This is the last concept. And ನಾನು ನಿಮಗೆ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ನೋಟ್ಸಲ್ಲಿ ನೀಟ್ ಆ್ಯಂಡ್ JEE ಕಾರ್ನರ್ ಅಂತಕ್ಕಂಥ ಒಂದು ಇಕ್ವೇಷನ್ ಇದೆ. ಆ ಇಕ್ವೇಷನನ್ನು ನಾನು ಸಿನಾಪ್ಸಿಸ್ CET ಸಿನಾಪ್ಸಿಸಲ್ಲಿ ನಾನು ಅದನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.